Alright guys, so this next video we're going to look at increasing and decreasing functions, and the most important thing in my opinion, for derivatives, I think this is the most important thing you'll learn all year. The first derivative test. For integrals, it's called the fundamental theorem of calculus, but you won't learn it until we get there next semester. But this is what we've been working for all semester to understand, okay, and the applications of this. Here we go. This right here is pre-cal interpretation. It's saying a function is increasing between two numbers is as if you go to the right, otherwise your x values are getting bigger and bigger and bigger as you go to the right. The y values are also getting bigger as you go to the right. Okay? But then I will be decreasing for two numbers as I go to the right if the y values are going down. So visually, this is going down. Visually, the y values would go up. That would be like a graph that looks like this, and this would be a graph that looks like that. That goes without saying. Now, let me show you an analogy that I used this morning. We are done with pre-cal. We don't want pre-cal telling us when f of x is increasing or decreasing. We want calculus telling us when that's happening. Okay? So will I ever look at f of x to see what f of x is doing? No, I'm not going to look at f of x. I'm going to look at f prime of x. Okay? Here we go. Check this out. Let me give you my analogy real quick. So first of all, the calculus interpretation, this is the one we're talking about. The test for increasing and decreasing functions goes like this. If the derivative is positive, then f is increasing. If the derivative f prime of x is negative, then f of x is decreasing. And if the derivative, or f prime of x, is 0, then f is constant. I know that's simple, but look at this. Let's pretend, because we're trying to see, it's all about f of x. It's all about f of x. And I'm going to tell you, my class can be seen as f of x. And when I test the derivatives, I can say that f prime are you guys. So next year, when you guys say positive comments about my class to students who are thinking about taking my class, when you say positive comments, I will increase in their head. If you say negative comments, then the chances of them taking my class will decrease. And if you say nothing at all, like neither positive nor negative, then it's still, their opinion is still constant of what it was before. We are not looking at f of x. We're not. We're trying to see what f of x is doing, but f of x is like behind a hidden curtain. You will never see f of x. But you'll know what f of x is doing because these will tell the story. You understand? So f prime of x says it all. What does f double prime say? It says the same thing, but of what function? F prime. So f double prime will rat out f prime. F prime will rat out f of x. You with me? So it's like, you understand, right? As far as just the analogy. Okay. So let's go to first derivative test. The first derivative test obviously uses the first derivative. This doesn't mean this. It doesn't mean that. It means the first derivative level from whatever it is that you're analyzing. So if I wanted to analyze the second derivative, I would need to rely on the triple prime to spill the beans, to tell me all about f double prime. Okay? So the first derivative is talking about this jump away from what you're trying to evaluate. Okay? Application goes through the roof here at the end of this unit for sure with optimization, maximizing and minimizing stuff. Okay? And it all stems from this. So C is the critical number. We need critical numbers first because we don't want to look at all the points. We only want to look at the ones that are important. And how are they important? They're important when the derivative at a certain x value is what? 0. Or if the derivative at a certain x value is what? Undefined. Remind me again, because some people with homework are struggling with this right now. When is a derivative undefined? When there is a variable in the denominator that we can set equal to 0. If we have a variable in the derivative that's in the denominator, and we set all the denominator pieces equal to 0 and solve for x, we will find where it's undefined.
How do you do that with the calculator again?
Menu solve feature, but you're not going to have a calculator on this. It will be, and if you do, it's only going to be able to calculate the optimization, the final answer for the pieces that you should have done by hand. You know what I mean? So here we go. Where they are 0 will come from setting the top equal to 0. Okay? Common theme. All right, here we go. Why is it that I can't just put, instead of from positive to negative, why can't I just put change of signs? You want to know which way it's changing. Because this right here is saying, here's your critical value, C. I'm analyzing the signs of f prime of x, so I'm going to test two intervals. I'm going to put test points from there and there. And if the signs give me that it changed from positive to negative, that's when I will have a maximum. And this is you guys. You are telling the story. Because you're telling the story of what's happening a whole level up, where this is my class. This is f of x. And you wrote positive, so it would be increasing. You wrote negative, so it would be decreasing. And the only way that you can go from increasing to decreasing is at a relative, what? Max. So f prime is saying what f of x is doing without ever looking at f of x. Okay? And then f prime, here we go. F prime, if it changed, if the signs changed at C from a negative to a positive, that's like saying from decreasing to increasing, that would be a relative min. Raise your hand honestly if you understand that. Okay. Here we go. We are going to look at all the steps involved to showing this. And these are those, the math is not that difficult, guys. It's not. The derivatives are lower level to mid-level. It's more so a conceptual understanding. Okay, here we go. Find the intervals where f is increasing and decreasing. As you read these, I think you should make little sub-notes. What do you think I want you to write next to f is increasing? What is positive? There you go. F prime of x is positive. And decreasing? F prime of x is negative. And if you want to put is positive and negative like that, you can do that too. Identify all points that are relative maximums and minimums, and these are points. If I ask you what is the maximum, you'd say the y value. If I say where is the maximum, you'd say the x value. But if I say identify all the points, I want you to give it to me like a coordinate point. And justify your answers. This is a test whether you know it or you don't. This is a unit to where you will either know it or you don't. You cannot fake pieces of this, okay? Because it's all connected. Very comprehensive, built on one another. All right. Use your results to sketch the graph. Okay. So let's go through the steps. Break it down piece by piece. What should I do to see when it's increasing or decreasing? Anyone? Find the critical points, and that means to do what? There you go. So find the derivative, set it equal to 0 or undefined. The derivative, everyone, is what? X squared minus. Okay. Can I set this x squared minus 2x minus 3? Can I set that equal to undefined? No, because there's no what? Denominators with x. So I can only set this equal to 0. Remember, critical points, it can either be 0 or undefined. So here we go. Factoring out. Do you agree with my factoring? Yep. So my zeros will occur at 3 and negative 1. So here, I'm going to put one at negative 1 and one at 3. How many intervals am I testing? 3. What is the name that you could give this number line? Say again? Yep, f prime of x. Okay? So now let's plug in numbers. You have a choice. You could plug the numbers back in here, or you could plug the numbers back in here. Let's say that I'm going to try like a negative 2. Which one do you think is easier to plug in? The second one, the factored form, because they will give you the signs very quickly. So I'm going to test a negative 2, and I'm going to put it right here and here. So negative 2 minus 3, negative. Negative 2 plus 1, negative. So the product is positive. That's how I want you to do it. What number do you think we could test that's easiest? 0. So when I plug in 0, the first sign is negative. The second sign is positive. So the product is negative. And what's my last sign? Positive. Okay? All that is just to, this is work, but please don't confuse this right here as justification, because it's not justification. Justification cannot be a graph. It cannot be a number line. It can't be pictures. Justification has to be words. Like becauses, like pers, theorems. Those are justification. Okay? So here we go. We're going to say f prime of x, or sorry, that's wrong. F of x increases on what? Yep, negative infinity to negative 1 union 3 to infinity. That was important, but what's more important is because what? Perfect. F prime of x is positive. Guys, if this was all trying to see what f prime was doing, this would have to be f double prime. Don't do that in your notes right now, but if it was looking for what f double prime was doing, you would have to analyze f triple prime, i.e. the first derivative test. Alright, so let's do the second piece. F of x decreases on what? Come on, someone knows it more than Braden. Negative 1, or other than Braden. Negative 1 to 3, because what? because f prime of x is negative. Alright? First part, done. Let's move on to the second part. Relative max and mins. How do I start that part off?
You have to take the derivative.
So we've already taken the derivative. We already found the critical points. We've already tested all of them. Here we go. The relative, leave a space, the relative max is at, where do y'all see the relative max? Nice. He doesn't even know what f of x looks like, but he knows that it's going to occur at negative 1. Okay? Nate, why?
Because f prime of x changes from positive to negative.
Perfect. Because f prime of x changes from positive to negative. Now, notice that I left a little space because I want to know later what that y value is. Okay? The relative min is what? Is at 3 something because what? Yep. F prime of x changes. So you got to be organized. Negative to positive. Okay? How would I get these values? Plug it into the original equation because we're talking about f of x. Okay? So if I plug in negative 1 over here into the original equation, you with me? For the sake of fractional practice, we're going to quickly do this with synthetic division. Okay? Now I'm going to erase this even though it was important work when we were working with it, but now I'm going to move on to the synthetic substitution. Okay, here we go. I have 1/3, negative 1, negative 3, 2, and I'm trying to see what would I get when I plug in a negative 1. Here we go. I'm going to copy this, multiply. See how good you're with fractions. A negative 1, which is a negative 3 over 3, minus 1/3. Negative 4/3. Times negative 1? 4/3. Here we go. A negative 3, which is negative 9 over 3, plus 5 or 4/3. Negative 5/3. So now multiply, get positive 5/3. And 2 plus 5/3 is what? 11/3. This is the value that's right here. Now I only did that for practice. Let's plug in 3 straight up. We're going to take this 3 and we're just going to plug it into the equation without doing synthetic substitution. 3 cubed? 27. Divided by 3? 9. Minus 3 squared? 0. Minus 9? Negative 9 plus 2? Negative 7. Okay? Yes, you can plug it in, but I'm telling you, the synthetic substitution is a skill you want to build because sometimes what it is and the big numbers that they are, synthetic substitution is better without a calculator. Okay? Here we go. Now I'm going to go to sketch it. This is the culmination. This is putting everything together. Okay, here we go. I have a point at negative 1 11/3. 11/3 is about 3 and some change. So about right here is that point where the relative max occurs. 3 negative 7 is where this relative min occurs. Okay? Alright, here we go. If I did a sketch, you tell me. Would that be accurate?
No,
Okay, y'all were fast with that. Why not?
because it should be differentiable.
Because it should be differentiable. Guys, what's the slope at these cusps right now? Undefined. What slopes did I calculate with my critical points? 0. So they need to be slow and smooth curves that are still relative max and relative mins. So they should have been drawn something like this. It was totally unintentional, but that's okay. This is pretty accurate because not only did I make those happen, but what also is my y-intercept? So you can do a pretty accurate sketch. Do you agree?
Yes.
Okay. Questions?
And then, are we ever gonna have to like plug it back into the original equation to find the zeros where it actually passes through the x-axis, or is that just gonna be like that?
There could be very rare times that we have to do that, but you know how to do that skill from algebra 2.
But that's just fine.
Yep, that's fine right now. That's good stuff. We good? I'm still gonna get deducted on this because I'm missing something. Remember I left a little space there?
The little triangle thing.
Not triangle thingies.
Justification.
So, justification, 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 right? All of those are justifications. His justifications are becauses, but what I forgot, I didn't forget, I didn't write it on purpose because I want you to bring attention to it, is per what?
This is called
Per first derivative test. No, it matters big time. This is why I wanted to save it for the very end. If you write per first derivative test here at the beginning of your problem and said, yeah, just use it somewhere in the problem, you won't get credit. I want you to tell me exactly where you use it, because this tells me that you know what really the first derivative test is. That you're not just saying, hey, just use it somewhere. I know where to use it, and I'm not going to be on a scavenger hunt to make sure that you know where to use it. No, I want you to tell me exactly where you used it. And more's coming with that we just did, okay? Yes?
So where do you?
So right here is where you use it.
But like, what is right here?
Right here, what I just boxed.
When you're just finding the relative minimums and maximums.
Per first derivative test, you will remind yourself, first derivative test, what is that? I'm using the first derivative, so are these. But that's not the first derivative test. That's not even a test per se. You're just looking at the signs and saying whenever it's increasing or decreasing. You see what I'm saying? But the first derivative test, put it in your notes, there are only 2 tests that you will learn, that you will actually need to write per first derivative test or per second derivative test. They both are only used for relative max and mins. That's it. First derivative test, second derivative test are the only things that you will use to get a relative maximum. Nothing else will you use. You just do it differently. Okay? Questions so far from this one?
So you find the increasing and decreasing and justify all that, and then first derivative test is just to find the relative minimums and maximums.
Okay, ready? Here we go. Let's keep going. They get more difficult, more involved. Okay? Attention to detail is still real high. Here we go. We're trying to see when is f increasing and decreasing. So already I'm thinking of f prime is positive and when f prime is negative. So let's go ahead and work it right now. So f prime, here we go. F prime of x is what?
2/3
2/3
times the stuff
times the stuff to the
Negative 1/3.
-1/3. Oops. All multiplied with what? 2x. Nice. So technically I have a 4x in the numerator. Okay? I'm going to get critical points from this. The important points. What's one of them that you see? What's one of the critical points that is important? Huh? Not 2. Or wait, I see what you're saying. You're doing the denominator right now, right? So Ryan went for the denominator and she set it equal to 0 because she's looking for the undefined slopes. And that happens where? Anyone? No. Like if we were to set this equal to 0. Okay, you ready? What would you do first? Divide by 3. What would you do next?
Take a cube root, or cube it.
Oh, that should have been a 3. Okay, so that should have been a 3. So I will cube both sides. Raise both sides to the power of 3. So that gets rid of this because it becomes 1, and 0 cubed is still 0. Now what? Add 4. Do you see where I'm going with this? What are my answers? 2 and -2. So my -2 and 2 came from the denominator. What's the top one? 0. So these are my critical points, and I'm going to sign test them with the derivative right here. I have -2, 0, and +2. I'm testing 1, 2, 3, 4 intervals. Okay, here we go. Arjun, what do you want to try plugging in for the first interval? -3. So we're going to test -3, and we're going to do it in the derivative. Arjun, what's the side of my numerator? Negative. What's the sign of my denominator? Positive. So what's the sign of the quotient? Negative. Okay? Omar, let's test something in between -2 and 0. What do you want to test? -1. Plug it in. What do you get for the numerator? Well, just negative, right? All we care about is the sign. Now plug in -1 for the denominator. Negative. So what is my sign? Positive. Taylor, let's do 0 to 2. What do you want to plug in? 1? Okay, what's the sign of my numerator? Positive. The denominator? Negative. And what's the quotient? Negative. Jordy, how about, what would you plug in for the last one? A 3? And what are my signs going to be? Positive, positive, so it's positive. So let me erase the scratch work. You understood as we went, but we built the sign test number line for f prime of x. Okay? Arjun, from here, you tell me what's right. Amy, help him out. What do I write?
To find the decreasing or increasing intervals.
There we go. So we're going to say, Arjun, we're going to say f of x increases on what?
-2 to 0 union 2 to
Perfect. But we need to do this because there's a lot of these points on the test.
because the sign is positive. Or because the
Because what signs are positive?
the function
Not f of x,
f prime.
f prime of x. Because f prime is spilling the beans about f of x. What's the decreasing one?
So f of x decreases on negative infinity to 2. I mean negative 2.
Okay.
Yeah. Union 0 at 0. Because prime of x is less than 0.
So the analogy, going back to the analogy, let's use f prime as a student. So I'm going to use Braden as f prime. F of x, Mr. Gomez's class will increase as long as Braden says positive things. Not as long as Mr. Gomez says positive things, because I can't describe my own class if I'm f of x. Okay? F of x, my class will decrease if derivative Braden says negative things about it to someone. Okay? Just want to make sure that you understand that first derivative jump. Alright. So those are done. Now let's talk about the maximums and minimums. How do I start this, Alec?
Do the first derivative test.
Yep, you got to say that right off the bat. So when you see these relative max and mins, we're immediately going to go to either first derivative or second derivative test. We haven't learned second derivative test yet, okay? And second derivative test uses the second derivative. We're not using the second derivative. So we're just going to say, like Alex said, we're going to say per first derivative test. Okay, keep going, Alec. What would I say as far as, let's do the relative max first. The relative max,
It would be 0, x value of 0.
is at x equals 0.
Yes.
So we're, because, and only because they said the points, if you don't see that word, don't use the points, use the values. We're going to put 0 something. Yeah, we can't use negative infinity because we'll never touch it. We'll never reach it. Okay, so we're going to put 2, and we might as well just do it now. Let's plug in this 0, Alec, into the original function, right? Because we need this y value to spit out from that. What would I get? So 0 squared is 0, right? Minus 4 is negative 4. And you can take the cube root of a negative. You could do that first, and that's what we used to do right at the beginning of the school year, and you'll do that most of the time. But because this is a negative, I think it'd probably be better to do this one first. So it's going to be the cube root of a positive what? 16. You all see that? Okay. And what times itself 3 times, anyone, is almost 16. It's like in between what two numbers? 2 and 3. Okay, so 0 and somewhere between 2 and 3. That's the point. Okay, so 0 and somewhere between 2 and 3. That's this relative max. And what was your because? Alec.
Was f prime of x. I remember how to say it.
Someone help him out.
Changes.
Changes. Okay, so this is the most important misconception right now. Is it positive or is it increasing? Should I say negative or should I say decreasing? For you to know what to say, you have to know what you just wrote. Sometimes it will be f prime of x is increasing, but that's not yet. We haven't learned that yet. But for right now, do you think I'd want you to say f of x increases or f prime of x is positive? F prime of x is positive because we're using the calculus to describe it. But this one is going to say f prime of x changes from what?
Positive to
Yeah. Okay. Matthew, what's the relative min?
-2, 0.
Okay, so -2, 0. Okay. Is there another one?
And then -2, 0.
And relative min at -2, 0 and at 2, 0. You'll see that? What's your because, Matthew?
Because changes from negative to positive.
Yeah, because f prime changes, you could put signs if you want, from negative to positive. So let's find these points right here. -1, 2, 0 and 1, 2, 0. So I have a feeling that you guys are going to watch these videos. I think you are, because you have to study for the quiz that you have on Thursday, okay? When we did this, I'm going to make a quick reference, right, real quick. These were when the derivative were 0 and or undefined. Okay? So we saw the undefineds occurred at 0. The zeros occurred where? Actually, no, I had that backwards, didn't I? When was the denominator equal to 0? At -2 and 2. You with me? And the top was equal to 0 at 0. So you tell me, can there exist a cusp at x equals 0? No, because the slope is what? 0. Can there exist a cusp at -2? Yes. Because that's when the denominator was undefined. That's when the denominator was 0, making the whole thing undefined. So I would want you to, it could be a cusp, it could be a horizontal tangent, or sorry, a vertical tangent, it could be a vertical asymptote. But this one, because it is an actual minimum, it can only be a cusp. This one can be a cusp. This one is a horizontal tangent, HT, horizontal tangent.
But how do we know whether or not it's a cusp or a asymptote?
Okay, so that's a really good question. If it was an asymptote, would these y values exist? No. They would be undefined in the original position function. And you see what I'm saying? And at the same time, you could have something that's changing from decreasing to increasing, which looks like it would be a minimum. But if it doesn't exist as a point on the f of x function, it doesn't even have a chance of being a minimum.
And then technically it could go from decreasing to decreasing, just like
Yeah.
the other side.
It could do decreasing to decreasing. Like if I had negative to negative, it could do decreasing to decreasing. There doesn't even look like there's a maximum. There's a lot of case scenarios that we're looking at right now. Okay? So, that's a good question, right? So, looking at this, we know it can only be a cusp, and the biggest reason why that we just verified is because we were able to find y values, right, from the original position
I
function.
forget, does it also just back that up because it has to be continuous?
Okay, so does it have to be continuous? On these, it doesn't have to be continuous. Those were only on Rolle's theorem and mean value theorem. This is something different. That's a really good question in timing, Nate, with that. These don't have to be continuous, okay? They don't have to be. And these graphs will not be continuous on certain intervals. That's only for mean value theorem and in Rolle's theorem. Okay, here we go. So, look, I'm going to help you out. And I wish I had the time to do this during second period, but I'm going to do it right now. This right here is the same. This is how we did like the position function or the velocity and the acceleration function before. This, and this. So right here, from negative infinity to negative 2, f of x would increase. Then, oh sorry, my bad. Thanks for the eyebrows. Not increase. It would be doing what? Decreasing, because it is negative. Yeah, you tend to tell me when I make a mistake, and I appreciate that. All of y'all. Decreasing. Then increasing. Then decreasing. Then increasing. Here we go. So I'm going to draw this graph. A graph that increases from negative infinity to negative 2. It's going to, decrease from negative infinity to negative 2 to a cusp. So decreasing to a cusp will look like that.
Does it have to like angle out like or like curve
Yeah,
out?
could you
Like,
make
like,
like an
could it be like a
absolute
straight
value?
line absolute value?
Because of what it looks like here, it will curve out. If it was just a linear and it was a lot more simple than that, then you could do what you're trying to do. Okay? Now, here we go. So that was this one right here. Now, between negative 2 and 0, I will, from a cusp, increase to a horizontal tangent. So from this cusp, I'm going to increase to a horizontal tangent. There is a cusp at negative 2, but there's not a cusp at 0. Here we go. Together again. We're going to decrease from a horizontal tangent to a cusp from 0 to 2. So decrease from a horizontal tangent to a cusp will look like that. And last but not least, we will increase from a cusp for the remainder. That could be the graph of what we just did. So remember when we would graph in pre-calc without a calculator? By looking at all the zeros, if it was an odd or even power, if it was a negative coefficient. Now we can do it to a much, much more in-depth level because of calculus. And we can do it faster. It's only taking long because I'm showing you for the first time. Okay? Questions?
How do you know it's a cusp and it's on the
Because at negative 2, we got that from the denominator of the derivative of this. Okay? And when the denominator is equal to 0, it will be undefined
But you can only check for that when there's a x or when there's a variable
on the denominator.
in the f prime function.
Okay? Think about it, guys. Think. Ask me those questions, please. All right, so that's enough of this one. They get a little bit more involved. We're going to get some practice with this last one. And next time when we talk, we'll be looking at more maximum and minimums, but going on to second derivative test, and you're going to see what that looks like. Okay, so please get a handle on your homework. I will assign the homework tonight. It will be due on Thursday. Your other one was due tomorrow. And then you will have a quiz on Thursday. Cool. There we go. So, same thing. Let's try to pick up the pace now. If you have a question, then you ask me, okay? I'm going to do it like if you were doing it for the quiz. F prime of x is low d high minus high d low over low low. My derivatives that are horizontal tangents can come from my numerator. My cusps will come from my denominator. So if I simplify stuff out, just a little bit, I have 4x squared minus 2x squared is 2x squared. And then, right here, minus 2x. You with me? The bottom is still 2x minus 1 quantity squared. Again, I want to get it to its most factored form. So simplifying and GCFing will give me 2x, x minus 1 up top, and then 2x minus 1 squared on the bottom. This is the one that I'm looking at. This is the one that I'm wanting to look at. Here we go. Let's build it. We will have, and I'm going to show both of them just so that you can see. We will have f of x, and we will have f prime of x. We're analyzing the zeros of f prime of x. Let's set the top equal to 0 for these horizontal tangents. What do I have? 0 and 1. Let's set the bottom equal to 0. What do I have? 1/2. A positive and a negative 1/2, or just 1/2?
Just 1/2.
Just 1/2. Good. And these are my cusps. So I would probably write right here a cusp and then horizontal tangent, just for side notes. Okay? I'm going to keep going up. I'm going to keep going up. Keep going up. So let's look at the 4 intervals that we're going to test on f prime of x. So if I plug in a negative 1, here we go. I would plug in a negative 1 here, here, and on the bottom. And actually, I wouldn't even plug anything on the bottom. Because the bottom is always going to be what? Positive. So if I plugged in a negative 1, I would get a negative, negative over a positive. Positive, increasing. If I plugged in, remember, all of them are positive on the bottom because of that squared piece. So let's plug in something like 1/4. So 1/4 would give me a positive. 1/4 minus 1 is less than 0, so it would be a negative. So a negative over a positive would give me a negative, which means it's, or f of x is decreasing. Something like 3/4. Yeah.
What's the question?
Oh, it's the same as the other ones. Increasing, decreasing, relative maximum. So something like 3/4. 3/4 minus 1 is negative. So positive, negative is still negative. Ooh, that one didn't change. That's something new. I can decrease to a cusp and decrease more. So maybe this is not a cusp. Well, we're going to find out here what it is. Do you see how I'm progressing? This cusp, you can't decrease and then decrease. You can't do that with a cusp. And you're thinking, well, maybe it's decreasing like this and then decreasing like this where it's a vertical tangent. Maybe it's a vertical tangent. But it's not any of those. Because at 1/2, if I plug it into my original function where x is at, the bottom becomes 0. So it's a vertical asymptote. Okay, and this is the third one that we're doing. So this would actually become a vertical asymptote. It's still non-differentiable. See what I'm saying? Questions? Okay, so let's test this last one. That's something bigger than 1. It'd be a positive, positive over a positive. It's positive, or f prime is positive, and it's increasing on f of x. Okay, here we go. So now, let's go to the pieces that we know. F of x increases on negative infinity to 0, union 1 to infinity, because f prime of x is positive. increases on, look at this, 0 to 1/2 union 1/2 to 1. I didn't put 0 to 1 because my sign at 1/2 is not negative. It's either 0 or undefined. So I broke it up and I put, because that's where f prime of x is negative. Alright, here we go. For first derivative test, the relative max is going to be at 0 something, and that's it. That's the only time where it changes from a positive to a negative, is at 0. Now I'm going to put, because f prime of x changes from positive to negative. I'll come back and, well, let me just plug it in now. Hey guys, if I plug in 0 into my original function, what do I get? 0. Remember, you got to plug it into your original function in order to see what that y value is on f. Okay, here we go. The relative min is at what, guys? 1/2, well, not 1/2. At 1, because f prime of x changes from negative to positive. If I plugged in 1 into the original function, I would get 1 over what? 1. So 1, 1. Okay. Alright, so now let's go ahead and graph what we have so that we can make sure that it all pieces together. Okay, so I have a point at 0, 0. I have a point at 1, 1. Let me make this scale a little bit bigger. So let's say that this is 1 and this is 1. And 0, 0 is the max. 1, 1 is a min. I know that looks weird already. But the way it's going to work is when we identify that my vertical asymptote occurred where? At 1/2. At x equals 1/2 is where I had a vertical asymptote appear. Okay? Here we go. Let's do this. Ooh, that's nasty. Let's do this better. Alright, so come on. Ooh, nice. Alright, here we go, together. Negative infinity to 0, we're going to increase to a horizontal tangent. So increase to a horizontal tangent. Okay? From 0 to 1/2, we're going to decrease to a vertical asymptote. Decrease to a vertical asymptote. And the max still happened. We're going to decrease from 1/2 to 1 to a horizontal asymptote. So decreasing from this vertical asymptote to a horizontal asymptote. And finally, we're going to increase from a horizontal tangent off to the oblivion. The relative max that we said occurred at 0, 0 is satisfied. The relative min at 1, 1 is satisfied. And all of these increasing, decreasing, increasing, decreasing to these things also did occur. questions?